Hi students, welcome to Evershine Coaching Center. Myself Faisal sir here. Dear students, today I am going to discuss the subject science in the topic magnetic effect of electric current. Dear students, in this chapter I am going to highlight the very important questions. Okay, from which are the areas you can expect the questions. I am just highlighting those areas so that you can start studying more and you can you can give more concentration on those areas. Okay, so those are very important questions, children, so you should not miss out those areas. Once in case if you are completing those areas, if you find sufficient time, then you can study the rest of the contents also, but first preference you have to give for the topics or for the contents or the areas which I am going to mark you people. Done? Let's begin. Look at here, children. This is chapter number 13, that is magnetic effect of electric current. Shall we start the chapter? Yes. In the previous chapter on electricity, do you think we want to start from here? No. What we have to see in the beginning before we start up the chapter, that is summary of this chapter, right? Let me go for the summary and then we come back to the chapter. Let me see what are the contents are present in this chapter. See here, children. Now point number 1, we can see here a compass needle is a small magnet. Its one end which points towards north is called as a north pole and other end which points towards south is called as south pole. Okay. Next point, a magnetic field exists in a region surrounding a magnet in which the force of the magnet can be detected. Always the magnetic field will exist only with the region surrounding a magnet. So where you have kept the magnet, it will just with respect to that surrounding only, okay, it acts. Got it? So within that region only we can detect, the magnet force will act only with respect to that region. That's it. Got it? Okay. Next point, field lines are used to represent a magnetic field. We have got a magnetic field lines. Okay. We usually use that to represent a magnetic field. A field line is the path along which a hypothetical free north pole would tend to move. The direction of the magnetic field at a point is given to the direction that a north pole placed at the point would take. Field lines are shown closer together where the magnetic field is greater. Next point we can see here, okay, that is nothing but a metallic wire, just a minute. Okay, a metallic wire carrying an electric current has associated with magnetic field. The field lines about the wire consist of series of concentric circles whose direction is given by the right hand rule. The pattern of the magnetic field around a conductor due to an electric current flowing through it depend on the shape of the conductor. The magnetic field of a solenoid carrying a current similar to that of a bar magnet. This point is very important. Okay, even this point, these 2 points are very important. Again you can just go through it. Electromagnet consists of a core of soft iron wrapped around with a coil insulated copper wire. This is the way we used to make the electromagnet, by using these materials. Okay. Next, is this clear? Okay. And next point we can see here, a current carrying conductor when placed in a magnetic field experiences a force. If the direction of the field and that of the current are mutually perpendicular to each other, then the force acting on the conductor will be perpendicular to both and will be given by Fleming's left hand rule. This is the basis of an electric motor. Very important point, children. Here he has defined what is Fleming's left hand rule, as well as Fleming's left hand rule is based on electric motor. Okay. So what is electric motor? Here we have the definition, we can see here. Electric motor is a device that converts electrical energy into mechanical energy. Even this point is also very important for 1 mark. Got it? Similarly, we can see here, the phenomenon of electromagnetic induction is the production of induced current in a coil placed in a region where the magnetic field changes with time. The magnetic field may change due to relative motion between the coil and a magnet placed near to the coil. If the coil is placed near to the current carrying conductor, The magnetic field may change either due to the change in the current through the conductor or due to the relative motion between the coil and the conductor. The direction of the induced current is given by the Fleming's left hand rule. Even this point is also important. Here in this point he has defined Fleming's right hand rule, here he has defined Fleming's left hand rule, and here okay, and in the previous step he has defined about solenoid. So these are the very important areas you people can expect the questions. You should be very much careful and you have to concentrate these areas a lot. Okay, from this chapter you can expect long high carrying marks. Okay, long answer questions you can expect from this chapter. Done? Okay, a generator converts, this is a definition of a generator. A generator converts mechanical energy into electrical energy. It works on the basis of electromagnetic induction. Very important. That is nothing but your dynamo difference, generator difference, motor difference. Then what is dynamo? Dynamo is a device which converts mechanical energy into electrical energy. What is motor? Motor is a device which converts electrical energy into mechanical energy. Generator is nothing but it is a device which converts mechanical energy into electrical energy. It works on the principle of electromagnetic induction. Okay, done? Okay, next point. We can see here, children, I can tell you one thing. This point is related to your domestic electric circuit. Okay, it is very important. You have to go through it. So from this, I am saying you all, from these points to remember this last summary, you can expect more number of questions. So you have to be very much careful. Got it? In our houses, we receive AC power of 220 volt with a frequency of 50 hertz. Usually, in our home, how much current we are going to get? That is 220 volts of power and frequency is 50 hertz. So this is the range what we are getting. One of the wires in this supply is with red insulation called live wire. Remember, you may have seen in the electric circuit. Okay, if any wire, if it is in a red color, that's nothing but live wire. Okay, the other one is in black insulation. It is in black color, that is known as neutral wire. Black color wire is known as neutral wire. Got it? Now the potential difference, okay, the potential difference between the two is 220 volt. So what is the potential difference between these two wires? That's nothing but 220 volt. The third is the earth wire. The third wire is earth wire. It is green in color. So that is green insulation. And this is connected to the metallic body deep inside the earth, the earthing wire. Because whenever if the voltage is high, if the power is high, what happens? Okay, it should not, we should not feel shock. Okay, any kind of hazard should not take place. So earthing usually they used to do for the home. So what happens? That high voltage current will goes inside the earth through the earth wire. So you should know this. Okay, red color wire is live wire. Red is live. Okay, and black is neutral. Black color is neutral. Green is earthing wire. Green is nothing but earthing wire. You should know the difference between these two wires and their respective colors. It's very important. Done? Okay, so why we used to do earthing? They may ask you the question like this, right? So it is used as a safety measure to ensure that any leakage of current to a metallic body does not give any severe shock to a user. Okay, so here we are using a fuse. So what is exactly this fuse? This fuse is the most important safety device used for protecting the circuits due to short circuiting or overloading of the current. They may ask you this question. Okay, what is fuse? And write the function of fuse. What is short circuiting? What is overloading? Okay, these are the basic definitions you can expect in your exam. I hope you have understood the introduction of this chapter, what exactly we are going to study here, right? So now let me begin the chapter. Okay, observe your children's magnetic effect of electric current. Here he has given some basics of this chapter. You can just go through it. Okay, now in this we can see one important point, that's nothing but, okay, in this chapter what exactly we are going to study. You can see here, in this chapter we study magnetic fields and such electromagnetic effects. Okay, we are going to study about this. We shall also study about electromagnets, okay, electric motor, which involves the magnetic effect of electric current. Electric motor, what involves? Involves the magnetic effect of electric current. Done? And electric generators, we have one is motor and other one is generator, which involve electric effect of moving magnets. So you should not forget this, both sentences. Understood? What electric motor involves? Magnetic effect of electric current, electric motor. But what electric generators involve? Electric effect of moving magnets, electric effect of moving magnets. So this is the important point you need to remember. Done? Okay. Next, so you can just study about this information. Okay, and after that, magnetic field lines. Okay, in this magnetic field lines, you can just read the entire topic. Here we have North Pole. We can see here there is a word called as North Pole and South Pole. North Pole and South Pole. We can study that. Okay, what is North Pole and what is South Pole? Now here we can see a compass needle gets deflected when brought near the bar magnet. When it will get deflected, when we bring near the bar magnet, then only the compass needle will deflect. So you should remember that basic point. Done? Okay. So you have to remember these two things in this paragraph, and you can just answer this question. And after that, we can see here. Yes, just a minute. Yeah, iron fillings. Can you see here? 1 minute. Yeah, you can see this magnetic field lines around a bar magnet. Yes, you need to remember this diagram also, children. How the field lines is been arranged. That is the setup. That is the setup of field lines around a bar magnet. Okay, and next here we can see very important points we are getting. Magnetic field is a quantity that has both direction and magnitude. Remember this very important point. So this magnetic field has both quantities, that is, it is both direction, it has both direction and magnitude. This is one point. Okay, the direction of the magnetic field is taken to the direction in which north pole of the compass needle moves inside it. Okay, you can just read this paragraph, children. But here one question you can expect, this is the question, like magnetic field lines are closed curves. How? Okay, how can you say that magnetic field lines are having closed curves? You have to give reason. At that time, this paragraph you need to study for this question. Magnetic field lines are closed curves. How? Okay, and apart from that, very important thing, you have to remember this paragraph. Which paragraph? This. The relative strength of the magnetic field is shown by the degree of closeness of the field lines. You have to remember this sentence. Got it? The degree, the relative strength of the magnetic field. So how can you get to know what is the, what is the strength, whether it is weak or strong? How can you get to know? Okay, we are going to check by the degree of closeness of the field lines. By the degree of the closeness of the field lines, we can check the strength of the magnetic field. It's one more question. How can you check the strength of the magnetic field? By the degree of closeness of the field lines. Again, I am repeating this point. This is very important. How can you check the strength of the magnetic field? By the degree of closeness of the field lines. Okay. Okay. If the field is stronger, that is, the force acting on the pole of another magnet placed is greater when the field lines are crowded. Okay. When can you say the field is stronger? So you have to write this sentence. Is this clear? Okay. Done? Very good. I hope you all are understanding these basics. Yeah. Now magnetic field due to current carrying conductor. Okay, you can just read this magnetic field, how it happens. Magnetic field due to current through a straight conductor. Even you can study this. Okay. Now in this straight conductor, children, one thing I will like to tell you, you have to write a short note on this. They may ask you this question. Okay, you have to explain magnetic field due to current through a straight conductor. You need to explain this. What you need to do? You need to explain this. You have to write a short note. You want to explain this point. Okay, you can read this entire paragraph. Please make a note. Please make a note. Briefly explain the magnetic field due to current due to a current through a straight conductor. This is important question, but not so much. It's important. Okay. It's just important. Here in this, I just like to highlight from here to here. The magnetic field produced by a given current in the conductor decreases as the distance from it increases. Magnetic field produced by the given current in the conductor decreases. When it decreases, magnetic field, when the distance from it increases. Okay, it has been given in figure. It has been noticed that concentric circles representing the magnetic fields around a current carrying straight wire becomes larger and larger as they move away from it. Got it? So you need to remember this paragraph, children. It is important paragraph. So when it becomes more, when it becomes less, okay, like the 2 or 3 mark question they can ask you, like 3 A, B, C, like that kind of questions you may get. From this all, they will choose one sentence and they can ask you one question based on that. Okay. Is this clear? Good. Next very important question, state Fleming's right hand rule. State Fleming's right hand rule. You can define it, and there is a problem. There is one numerical here. You can solve this numerical. You can solve this numerical. Done. Okay, and you can answer these questions which has been given here. And children's, this magnetic field due to current through a circular loop. Very important question. Very important question. This circular loop and solenoid. Okay, circular loop and solenoid. These both questions are very important, children. You should not neglect. You should not neglect. Okay, here we can see from here this point. We know that magnetic field produced by a current carrying straight wire depends inversely on the distance from it. Okay, you can just read this paragraph till here. Okay, you can study till there. That is one paragraph, and after that this is second paragraph. From here to here we can see this is second paragraph. So in this, that complete magnetic field due to current through a circular loop is been explained to you all. Done. Okay, you want to study that. Is this clear? And next, very important topic, that is magnetic field due to current in a solenoid. Okay, you have to study this topic. Very important. I can't say in what way the questions can be asked, but definitely you can expect the question from this solenoid topic, from the topic of solenoid and electromagnetism. I mean electromagnet, and their uses also you need to write, and you can answer these questions. Okay, and even this question, force on current carrying conductor in a magnetic field. You want to describe this experiment. You want to explain this experiment, how force on current carrying conductor produces in a magnetic field, how the force is exerted on a current carrying conductor when it is placed in a magnetic field. This is what you need to explain. You want to explain this. Okay, it's long carrying marks. Okay, long answer carrying questions. In that you can expect this question, that is circular loop, solenoid and current carrying conductor, force on a current carrying conductor. So these topics you need to understand, and you want to write a short note on this. You need to write a short note on this. In this we have Fleming's left hand rule also, and you can solve this numerical, and even this problem you can answer this question. And children's, magnetism in medicine. Please study this topic, how magnetism is used in medicine. Okay, maybe you can expect a question on this topic, because nowadays medicine is very popular because of certain diseases. Okay, hope magnetism also can give a remedy. So the examiner can ask you the question based on this topic. You want to study this topic also. Okay, and electric motor, I can tell you here, the question can also be asked for you in this way. Briefly explain the construction and working of electric motor. You want to explain this entire structure with a neat diagram. Explain the construction and working of electric motor. Okay, is this clear? you want to explain this, and even you want to explain this concept also, what is electromagnetic induction. Okay, and you have to explain the construction and working of Faraday's experiment, that is also called as magnet coil experiment. You want to explain this electromagnetic induction phenomenon. Got it? And you want to write one more question, write the factors on which the EMF induced in a coil. Okay, if you want to induce the EMF in a coil, okay, what are the factors are responsible? So those factors also you need to name it. And why did Faraday place calico cloth in between the layers of the copper wire? That is one. And apart from that, he may ask you an experiment like, if magnet and coil both are stationary, can you find any deflection or not? Okay, in the galvanometer there is deflection or not. When there is relative motion between these both, what happens? If one is stationary, one is moving, what happens? One means magnet and coil. Got it? If both are moving, what happens? If both are stationary, what happens? If one is moving, another one is not moving, what happens? So like that kind of conditions he can ask you, and he can ask you the result on those areas. So you need to remember those points, especially in this concept. Understood? Is this clear? Yeah, about electromagnetic induction. Again I am repeating, what is electromagnetic induction, and briefly explain the construction working of Faraday's experiment, or explain magnet coil experiment. Write the factors on which EMF write the factors on which the EMF is induced in a coil. Okay, on which EMF is depending. So write the factors on which EMF is induced in a coil. So what are the factors are responsible for that? And next they can ask you some observation. Based on observation, any question can be asked. But on the whole, these all questions carries 3 marks. Okay, you need to remember those things. And here, see children, please make sure that you can get a question on this topic, that is current is induced in coil 2. Okay, coil 1 and coil 2, when the current is in coil 1 is changed. So based on this relative motion, based on this, how the current is induced from one coil to another coil. We are passing the current in one coil, but we are obtaining the current in another coil also. How exactly it is happening? It's very important question. See children, this chapter is meant for long answer carrying questions. Okay, you will be getting the questions maximum long answer carrying questions. In that you can expect this chapter. So what is galvanometer? It is a device which is used to detect the presence of electric current. Okay, that is nothing but galvanometer. Okay, and next you can just answer this question. Next, even here also explain the construction and working of electric generator. Explain the construction and working of electric generator. You can study, and write the difference between AC generator and DC generator. Differences they can ask you between AC generator and DC generator, and they can ask you the graph. They can ask you the graph. What is AC and what is DC? What is AC and what is DC? Okay, see children, this is our alternate current, this is alternate current, and this is direct current. In alternate current, what happens? The graph will be in this shape. In direct current, the graph will move in this shape. Should not forget it. Okay, this is x-axis and this is y-axis. So this x-axis what represents and y-axis what represents? X-axis represents electric current and y-axis represents time. You should not forget, y-axis represents current and x-axis represents time. Time is measured in seconds. Current is measured in amperes. Current is measured in amperes. So you should know this circuit diagram. I mean, you should know this graph of AC current and DC current, alternate current and direct current. Done. So this is of AC and that is of DC current. So maybe hope you can get the question like that also. Okay, so you can study those things, and so please you study that entire paragraph. Done, and you can answer these questions. and domestic electric circuit. This exercise, I mean this paragraph is very important for your board exam. So in this many questions are there, okay, but basics, short questions like one word answers questions, okay, like as what we discussed over there. Example, live wire, can you see live wire, neutral wire? So what is the color? Just now we have discussed. And what is the I mean how much power is supplied to our house? That is 220 volt. Can you remember? That is 220 volt of current and 50 hertz frequency. Got it? And you can study this complete paragraph you can study, and please write one line what all you find as important. Fuse, okay, earthing, so these things. And if possible, try to draw this diagram, practice this diagram, schematic diagram of domestic electric circuit. You can study the diagram also, okay, but it is not given in your exam like list of diagrams, but you can draw the diagram. It will give you still more good marks, okay. So that is what we have done in this chapter. Is this clear, children? So these are the things which we want to concentrate in this chapter. I hope you all have understood what are the contents, means what are the things we want to study in this chapter, how we want to start preparation for this chapter for the upcoming board exam. If you have liked this video, okay, do not forget to subscribe our channel Evolution Coaching Groups. Like it, share it, comment it, and subscribe it. Done? Is this clear? And our YouTube channel is Evolution Coaching Groups. Do not forget to subscribe it to get the latest and updated videos. Thank you for watching. Wish you all the best of luck. Do well.